Good morning. Welcome to Mitigating Environmental Noise from the Operation of Mechanical Equipment. I'm Scott Arnold, Senior Manager of Publications and Standards for Air Movement and Control Association International. On behalf of our more than 400 members worldwide, I want to thank you for joining us. We realize there's a lot to see and do at the AHR Expo, and we respect and value your time and hope you find this educational session worth your while. The information contained in this session is provided by AMCA as an educational service. In making this educational activity available, AMCA is not endorsing, sponsoring, or recommending a particular company, product, or application. This session is protected by U.S. international copyright laws. Reproduction, distribution, display, and use of the material without written permission from AMCA International is prohibited. And with that out of the way, let's meet our presenter. As Director of Sales North America for Kinetics Noise Control, John Sofra manages sales and marketing efforts for the North American industrial, environmental, and airflow attenuation markets. This encompasses sound and vibration isolation for industrial in-plant equipment and processes, outdoor mechanical equipment, and ventilation sound control for HVAC duct systems and industrial fans. He has served on numerous ASHRAE technical committees for acoustics and vibration and taught continuing education courses on ventilation and acoustics at the University of Wisconsin-Madison. John?
Thank you, Scott. So I just looked, we have 34 people that are very interested in outdoor noise control. So we're gonna have a big party over my house because I love outdoor noise control too. So your lucky day today. So learning objectives as we go through this, as we start, so you kind of know where we're headed. We want to identify the characteristics and need of a well-written noise ordinance. I think that's where it all starts, is do we have to control the noise? What are we going to do? What's fair to the community? What's fair to the entity that's making the noise? Explain why sound spectrum and sound spectrum shape of a noise source across each of your 8 octave bands, 1-to-1 center frequencies, is important. You can't just say I'm at this dBA overall A-weighted sound level of, say, 100. We need to know what the equipment is. Describe the factors affecting an outdoor sound propagation path. How's the sound actually going to get from the source that's making that sound, or shall we say noise, to the neighbors? And then compare the different products and solutions. A lot of people say there's nothing that can be done. And I think the interesting thing is that there are things that can be done. And I guess I've always had this, like the last one, he loves to be challenged by the phrase, it can't be done. I think that's something I've always thought about as I got out of college many, many years ago. There's an article, this presentation is basically based on the article that was done in 2023, distributed at last year's AHR Expo, and it's the 2023 AMCA In Motion magazine. So you can go on to the AMCA website. You can take a look at that. It's very easy access. I have a couple hard copies back at the house and pass it around the office for training, but it's on the internet. You can access it very easily. So everything you're going to see here is in there. We're going to first, a little introduction, kind of what we just did now. Sample outdoor noise ordinances, what's fair, what's not. It's just a couple of slides. Primary sources of environmental noise due to mechanical equipment. In support of building HVAC and power systems. What you're going to find out is there's people say, what kind of noise do you quiet? And mechanical systems are endless almost out there. We're going to limit it to about 4 different pieces of equipment that are the most common culprits of noise issues outdoors. And then we're going to look at applying products, ventilation silencers, acoustic louvers, barriers, enclosures, stacks, something called a pergola, and all these sound absorption products. Now, I always like to say outdoor noise equals community noise equals noise pollution. I mean, that's whatever you recognize, that's what we're talking about here. One thing we're not going to cover, we talked about mechanical equipment. What we're not going to cover here is like amphitheater noise. Rock concerts, things like that. We're not going to go into that because actually back in 1980, there was a new clause amendment to many noise ordinances around the country. And it was actually a rock band by the name of AC/DC helped write it. And that is rock and roll ain't noise pollution. So we don't have to, that's my little icebreaker for the beginning, but I like it. And as I was drinking my coffee this morning, I thought something new that would be interesting. But seriously, noise is an issue and a problem outdoors. WHO, noise is among the top environmental threats to physical, mental, and well-being. I think we all know that. I can't stop at a stoplight and be boxed in by other cars and somebody have their bass just driving in their car. Well, I don't have hair, but it would make my hair fall out if I did. It just drives me nuts. Some people don't like high noise levels. Some people don't like noise levels that maybe are there now because something was built, a commercial building was built, and there's mechanical equipment outdoors, but in the past, that noise wasn't there. It may not be overly loud, but it's there now, and they notice it. Need to educate, in other words, need to educate the community, city officials, building owners that may have never had to deal with noise issues. And one of the reasons we're dealing more and more with noise issues probably came on pretty strong in 2006 and just as crescendoed over the years as a demand and a need is that industrial areas zoned industrial, commercial, and residential are all mixed up now. It used to be a buffer. You'd have a residential community over here, you'd have a commercial, and then you'd get to the industrial area that might be allowed to make more noise. But now you have an industrial facility, you've probably all run into this, and all of a sudden, a 350, 500,000 home subdivision goes in next door. There's no buffer in there. And a lot of times, many times now, in those cases, especially when it deals with tax dollars, property taxes, things like that, the entity that was there first, maybe the factory, they don't get grandfathered in anymore. Okay, there's a lot of things that need to be done. And we want to develop something fair and obtainable. I think we'll all agree, too, that the cost of remedial work usually exceeds that which was properly planned and anticipated. The reason I mention this is over the years, people would say, I think we're going to have a noise problem. Let's say they're building a new hospital or a library or a worship space, church. And they were going to put in some air-cooled chillers and things and next to a neighborhood. And the architect, acoustical consultant, let the owner know that, there could be a noise issue here. We're new to the community. There could be a noise issue here affecting the neighbors. And the owner may have said, this is 06, even up to like 2018, 2019. Well, new construction, maybe we won't have a noise problem. I'm not going to worry about it. I'll cut it out of the budget. We'll just cut it out of the project in the 11th and a half hour. Just to find out a year or two later, people come back in and say, hey, we got a noise problem now. Now you can retrofit it, but usually it costs more. So that's all I'm saying here. What we've seen since 2019, if we had to put a date on it, to present, we're seeing more and more projects in new construction where noise control is not getting budgeted out. And it's a beautiful thing because it's always easier to plan, place, maybe even relocate the equipment sometimes to control noise or quieter equipment. When you look at an outdoor noise ordinance, you look and you say, okay, something that is too subjective. This isn't fair, the first one. And this is in many noise ordinances is written like this. Noise levels in the city limits shall not exceed those that bother surrounding neighbors. Well, that's pretty subjective. I just told you I don't like being stuck in traffic with all that bass beat. Somebody really likes that. Subjectively between us, it's not the same. So we don't want something like this. And very often, it may be a community that's complaining about noise is up against this because they haven't updated their noise ordinance. The other one that's too stringent is if you have a broadband noise like mechanical equipment outdoors, air-cooled chillers, cooling towers, things like that, is any noise level that exceeds ambient noise levels by 5 decibels or more in any octave band. So you might go from 63 hertz to 8,000 hertz, 1-to-1 octave bands. Of course, those are made up of third octave bands and so on and so on. But in any one of those, you can't be over 5 dB. Now, just for reference, a 3 dB increase, let's say within a frequency we can hear well, 500 hertz, and you go from a 90 dB at 500 hertz to 95 dB at 500 hertz, most of us aren't going to be able to tell the difference in loudness or perceived change. 5, you will sense some, but it's just not applicable to more of a broadband noise source. Now, if you have a pure tone, like a power plant, you have a stack, and it's generating noise at, I don't know, 58.9 hertz or something, or lower, or 45 hertz, you can control, or 125 hertz, you can then get into that discrete frequency range and control that, and this might be applicable. Something that would be fair, and this is a well-written one here, this one actually lists out a lot of stuff. It talks about, if you look in the leftmost column, we list it by a low-density residential area. And then daytime standards, you're allowed 60 dBA in this example at the property line for any 1 hour period. At night when we're sleeping where we want it quieter, you're allowed 50 dBA. Now that's a low density residential area. You start getting a larger residential, higher density area, that increases a little, gives you a little break. But it's still 65 dBA during the day and 55 dBA at night. And you can see the time zones like 7 a.m. to 10, and then 10 p.m. to 7 a.m. when you're sleeping. Now, when it's commercial and manufacturing use, you're allowed 70 dBA in the day and at night. But what happens when you all of a sudden have a low density residential area and then a factory moves in right next door? So they're only allowed 50 dBA at night, but now the factory's 70 dBA at night. People need to start talking and figure out what they're going to do. Just for instance, conversational speech is 60 dBA. I can be louder even without a mic, but 60 dBA. Light auto traffic at 100 feet is 55 dBA, and that was at 100 feet. And then your residential AC in the back is 50 to 60 dBA. Now, I didn't talk about loads or anything like that on the equipment yet, and that'll vary the noise levels as well. So what we want to do with a noise ordinance is where clear ordinances are set forth and they're fair, even if they're not fair. If they're not fair, you have to fight them a little bit, but where they're set forth a fair and equitable noise ordinance, the owner may be forced to reduce the noise levels by some engineered solutions or be fined. We know that. Citations can be monetary fines or shutting down. We had this one bakery that was had a bunch of exhaust fans on the bakery, and it was making a lot of noise, and it was in an old neighborhood. There was no new subdivision. They just changed the codes. And this bakery actually had to put silencing on top of all the general building exhaust fans, or they actually, for, I think it was, they went through about 4 days that they had to shut the bakery down. And so I thought that was interesting. But the fines and just looking bad in the community where their noise ordinances are not set forth. We got a lot of noise ordinances around the country, or I'm sorry, territories, cities, municipalities, townships around the country that do not have a noise ordinance. But the companies that may have moved in that are making noise, they'll elect to take it upon themselves to control the noise, to be that good community, good neighbor in the eyes of the community. I think this is interesting. One thing we like, I know many of us that are in environmental noise control, we really like it because you get involved with the community, you get involved with the owner, you have to talk between the two, you got to make peace, you got to tell them what's true and what's not. If they tell you you're going to get this noise reduction and you're not, you have to educate the community so they can believe and understand, so you can get to that point where you actually do this engineered solution and they're like, wow. We call that the ooh-ah moment. Ooh is like, wow, that's loud. Ah, wow, the solution worked. So ooh-ah effect, we call that. I don't know if that's published anywhere, but that's what we call it, the ooh-ah effect. So what makes all this noise? I mentioned that there's a lot of things that make the noise, but the most common things that we deal with in mechanical equipment on a daily basis, doesn't matter whether it's a hospital, a library, a factory, a convention center, shall we say, it doesn't matter. You're going to look at, or a data center, which is real hot right now, of course. You're looking at air-cooled chillers. They could be on grade, they could be on the roof, depending what's in the area and what the noise ordinance is, whether there's condos next door and they're above the roof, or whether there's main entrances on the ground at property line and houses. We have to take a look at this. Now this is twofold, which we'll talk about. We'll get into more, but it's a compressor noise and an upblast fan noise that you have to control. And they run about 98 to 102 dBA unattenuated as a sound power. Another one are cooling towers. I love this picture, but a bunch of cooling towers. Once again, they got intake noise. These are induced draft cooling towers. No really external static. We've got to be very careful about quieting them down and pressure drop and all that. Propeller fan noise, intake noise, both must be addressed. And once again, these run about 86 to 100 dBA unattenuated at the unit sound power levels. We have to look at air handlers. You'll see a lot of buildings with multiple air handlers lined up. We know we have the condenser fans, we have the air intake, we have radiated casing noise. That can be anywhere between 180 to 100 dBA. And then one of the biggest things is constant power, especially with all the power demand of data centers even. You know, we talked about AI. I heard something, I forget the other day, something like 13 times the amount of power required in an AI search versus just a regular search. It was somewhere there. I was listening to it on the radio. So there's a lot of power coming in. Well, these generator rooms are great. You walk in there, you want some muffs. It might be running 100 to 110 dBA within that space. So maintenance goes in, where the muffs, that's great. But there's noise that breaks out of that room, right? You got the fresh air intake noise, and you have the discharge, let's say it's radiator cooled off the radiator. Well, the noise within that room, that's bouncing around and becoming worse, and there may be multiple units running at a time, maybe 6, 7, 8, 10 generators working at once, or vice, or some mix of that. That noise is going to break out to the community. It's a beautiful thing. What I like about that is the community hates that noise, which means they want you to engineer it out and show them what good things you can do as an owner, as an engineer, an acoustical consultant, architect. So we're going to take a look at that, about 2 ways we can solve that noise. Most important factor to know how the noise source works. Acoustics, I tell, we hire new people, or people come around, or we talk. Acoustics, if you know acoustics, that's the back of your hand, okay? You first look at where's the equipment, how does the equipment operate, and can something be done? If that can happen, sometimes you might have to encroach upon the mechanical equipment more than you would expect, or more than the manufacturer would like, and we got to worry about warranties and things, and we got to work together, and we got to prove how it's going to breathe properly. And then you look at maintenance access. What kind of access do you need? So the important thing is, I can't stress it enough, it's not only good to know acoustics, you got to know how the equipment operates. And that's very important. I've seen a lot of projects where people have just blindly gone in, and I'm not talking just the owner here, other engineers and things that have gone in, and the equipment's overheating, or there's maintenance issues. There was catastrophic failure, and it costs more to tear down the solution to get the new unit in than the new unit costs. So we know most mechanical equipment is not designed to operate under the adverse effects of being enclosed or being close to a wall or a barrier or down in a pit. So we're going to talk about all that, but all that is very important. And all these years, I've been in this business for about 36 years, probably the last 21 years was all in the environmental and working with many manufacturers of equipment to see how this can work, because they're finding their equipment VE'd out noise control, and now we got to shoehorn in a solution. What is realistic, though? And as you go through this article, what is realistic? I thought this was good. So if you're looking at a fan outdoors, either up on a roof or a dust collector next to a building, what's realistic? Well, you can expect about a 25 dBA drop at about 5 feet away from, say, the discharge of that fan, at about 0.35 inches water gauge static pressure drop. That's realistic. If you need more than that, can it be done? Oh, yeah. But you might need you might have to slow that velocity down and slow the airflow down. And so it can be done, might be more expensive. But what we want to do is, the most important thing was the pressure drop. We need to make sure, if that's connected to a dust collector, that the dust collector continues to operate and pull and entrain and carry particulate or fumes throughout the system. So that's realistic. Now, if we look at an air-cooled chiller, you have the upblast fans, you have the compressors at the bottom. There's a lot of different products you use. We'll get to that in a second. But if we put a wall up, and let's say there's an air-cooled chiller in the middle of this room, and we got a wall all the way around, not this tall, but let's say 10 foot tall or 12 foot tall. It's realistic to see an 18 to 23 dBA reduction 90 degrees away on the outside of the wall from the equipment. Out the top, there's some things you can do that allow it to breathe properly, and you can get, let's say you got a pit here of air-cooled chillers, but you have condos and balconies above it, and you can realistically get 8 to 10 dBA reduction at 10 feet above the units, at a total system pressure drop of 1/10 of an inch from the intake to discharge, 1/10 of an inch. Basically, it's almost like the solution is invisible to the equipment. And that's the key, right? You want to keep the equipment operating that doesn't have a lot of external static available. So those are some things we'll talk about. Remember too, I know when you say here, oh, induced draft cooling tower, there's actually an INTS paper and an ASHRAE paper written on that also talks about you can get 10 to 20 dBA reduction at 10 feet from the intake and discharge of an induced draft cooling tower, something that doesn't have a lot of external static at 1/10 of an inch. What's interesting here is you say, 10 dBA, big deal. Well, a 10 dBA is going to be perceived by all of us as sounding half as loud as it did before it was quieted down. So 100 dBA reduced down to 90 dBA is going to be perceived as sounding half as loud. It's a huge deal. And that's because of the logarithmic nature of it. When we first start a cost-effective solution, we want to first get as much information as we can. Now remember, you say, okay, typical information on an air-cooled chiller, we'll get the data sheet, the dimensions, the airflow, all that. On a cooling tower, same thing. On a fan, same thing. But we could have some product out that we're working on that we may not know a lot about. So you want to get a lot. Remember, you want to know exactly how the equipment operates, how you service it, maintenance access even. And then analyze all the sound paths. If the equipment's here, are the neighbors up on a hill? Are they below? Is the noise source on a hill? Is, what's in between the neighbors? How far away are they? Are we worried about, I've even seen noise ordinances written that don't, this is the weirdest thing, but I've seen it a few times over the years, is instead of having the allowable sound levels at the property line, at maybe 5'5" average ear height above grade, mine's 5 foot, but average ear at that location, sometimes they'll say, no, we need it at a certain level because we're worried about the second story house windows being open and things like that. So you just have to look at where everything is located. So when you look at the source, you want to know the airflow, the airstream temperature. Does it generate heat, the casing, the horsepower, equipment configuration, dimensions, and installation guides? That last one is probably the most important, and then ranking down to airflow and equipment access. So if we look at this, factors to consider on the path, are we up on a roof? And we're worried about the neighbors here that are just as high or higher. Same thing here. This is a hospital. See the heliports, but this is a hospital, and we got a bunch of mechanical equipment on the roof here, and we're worried about noise going across and breaking into those windows of the hospital. We have a beautiful neighborhood back here, and somebody decided, we're going to pop in some new cooling towers here. Now, this one's really interesting. You can analyze this and see how much noise is actually going to end up at the property line here. And what you find out is you may meet that noise level. There's no, at nighttime and daytime, and there's no problem compared to when they operate. There's no problem. But sometimes it's an out of sight, out of mind. Is they said, hey, when we moved in here, we didn't see no cooling towers back here. It was just a field. So sometimes we talk about, we investigate, is it the noise issue? Well, we're meeting the noise at the property line at 100% equipment load. Well, then you find out it's really the visual thing. So sometimes owners will go ahead and put up a visual fence, non-acoustic visual fence. We also want to look at community sensitive areas. Is there published noise ordinance? A lot of times there's not. So the entity that's making the noise might want to be a good neighbor and solve it anyway because it costs money, right? Requirements of a noise source. Who was there first, the noisemaker or the neighbor? We continue to ask that question all the time, and we find out more and more it doesn't matter. Nobody's getting a break. But that can be an issue sometimes. We can get a variance on the noise ordinance if there is one. Topography, we want to know the elevations between the noise source, the distance, where the property line is. And then we also look then for bringing it all together, source path receiver. We look at the equipment manufacturer's warranty and installation guidelines. If you need to put a barrier wall up around, let's say, an air-cooled chiller, whether it's up on a roof or on grade, or you make that barrier wall, instead of acoustic panels, you make out of acoustic louvers, because the architect loved that acoustic louver look, and you get a lot of airflow in at a low pressure drop. If we can stay within the guidelines, where the manufacturer says you shall stay this far away from these sides of the air-cooled chiller, that's beautiful. But sometimes you can't. because it's retrofit and you got to shoehorn in a solution. So then we want to look at all that. We want to balance, and then you'll see people should put a report together if the manufacturer's questioning, if the manufacturer's not familiar. They should have the entity that's trying to put the solution and put a pressure drop as well, a report together, why it's going to work, also acoustics report. Local codes, we want to look at electric. If we really don't want to infringe more than electric code, because it's kind of governing more than anything. So we want to stay away, what is that, 42 inches, 52 inches, 48 inches. Local noise ordinance, location of equipment dimensions, maintenance access, very, very important. We don't want to make it hard for general maintenance to be done on it. And that's very important. And then structural support. Sometimes, I was always taught long ago is that if you put in a solution that's going to control noise either on, let's say, an exhaust fan, and it's an upblast fan, and the noise is, it's an upblast fan, and the noise is propagating out that discharge, and the neighbors are complaining, that silencer should not sit on that fan to that extreme. It should be externally supported. Okay, the equipment wasn't meant to support that, and it wasn't meant in seismic load areas, snow, or wind moment forces, things like that. So always make sure everything is externally supported and not supported by the equipment. Maintenance access, we talked about that. Doors, hatches, which is easier. If you have an access port, is it of a certain weight that can easily be taken down and put up by one person? All these things that are very important in all the solution-based. Now, if you look at a ventilation fan, once again, get the data sheet, installation guidelines, length, width, height of the footprint, inlet and outlet dimensions, airflow, inlet, outlet, ducted, non-ducted or unducted, and casing radiated noise. Field sound levels, sometimes it's an old fan. It may be working at a completely different operating point than it was designed for, and that's how they got to operate it, because they don't want to buy a new fan. And so there is no sound data, so you got to go out and have somebody take some octave band sound data. I like this because many of you know already, is that a fan is not a fan is not a fan when it comes to sound, and this shows you different sound levels. So a prop fan tends to spike out at about, I don't know, what is it, almost 250 hertz. And then the noise levels, this is sound power level here and frequency here. You got backward centrifugal, you got pretty much a low frequency noise, and then you have I think the one here, radial, yeah, you got a lot of low frequency noise and less high frequency. So it's very, very important. You're gonna have different solutions, let's say for a silencer on the discharge of these. This is a good one here. A lot of times you'll get a call and you say, hey, we're running at 100 dBA, we got a centrifugal fan. Well, not a centrifugal fan. We have a noise source, we don't know what it is, but we're running 100 dBA. Well, you need to have the octave band data, because if you look here, by definition, when you run the calcs, both of these curves run at 100 dBA, but they would both have two different noise control solutions. This one has a lot of low frequency noise. A lot of low frequency noise, and to perceive that, there's a lot of energy there to have the same equal loudness. And so there's a lot of energy you need to eat up there. It would be a completely different solution than if you went with this 100 dBA level noise source. In fact, this one would be easier to solve, or less expensive. They could both be easy to solve, but this one would be less expensive. So it's very important. 200 dBAs, overall noise level, two noise sources, but they have two different sound spectrums, two different noise solutions. If you look at the ventilation fans too, you can do a couple different things. You can see we looked at the casing rated noise, the fan intake and discharge noise. The top picture there would be an enclosure, sound enclosure around the fan. You want to make sure that enclosure is ventilated properly based on the horsepower of the fan. And then if you have to put in some inlet areas or an exhaust, fan-powered exhaust for just to ventilate the heat, you want to make sure those sound paths are quieted with silencers. You can also sometimes just put a barrier wall around an equipment yard or a fan to control noise, and you can do analyses to determine whether you're in the shadow zone close to it or whether you're getting a reflective up and over diffraction. You can put a silencer on the discharge of a fan, as you see down at the bottom, or on the intake. Sometimes you might have to do the top one and the bottom one, or both of these, the middle and the bottom. It's just a lot of things you can do. If you look here in the upper left-hand corner, this is actually a fan at the AMCA laboratory. And what I like is we don't get good pictures of silencers on fans. And what's really nice here is it's a nice round intake silencer with an internal sound-absorbing bullet and a perforated inner shell and insulation thickness. So you're getting the best of the best here based on balance of pressure drop on the intake and acoustics versus a function of length and diameter. And then also here you have a rectangular discharge upblast. So that's really cool. Then over here we have a dust collector. Typical, it could be a compound outdoor noise issue. They're worried about the fan casing rated noise, so they put up a acoustic double wall barrier wall system, and then a discharge silencer. Neighbors were not far away. This is a dust collector. If you notice here, this one's really robust, I will say, but they did an externally supported silencer with all the steel here. You can look at a couple different things. This one here is on general exhaust off a building. Both these are general building exhaust. This one's actually off of a Purina, or they were making pet food. And what happened was, if I remember when we went up here, it just smelled like dog food all over. But what they did was there were neighbors where I'm standing, big row of neighbors. This roof is probably, I think, that's probably a 40-foot bay building. It's probably 40 plus feet above grade. And the neighbors were complaining about the noise. There were many of these general exhaust areas and clean air off of processes. So there's a circular silencer here and a saddle brace, external saddle brace support here. And then there's a 90-degree gored elbow, 5-gore elbow here, and they actually turned that away from the neighbors. So kind of did a double duty to fine tune the noise reduction. The silencer itself didn't do the best. We had natural attenuation of this elbow. The silencer wasn't perfect, but for insurance purposes, the elbow was turned completely away into a field where there's nothing yet. There's nothing yet. So if it was noisy over there, no problem. So that was one thing to do. And then here we have general exhaust. Once again, a simply supported vertical silencer above general low static pressure exhaust fan for a building. I think there's like 42 on this building here. And I forget the diameter of those. I have a picture. I didn't do it. Air-cooled chillers. We talked about that. We've been talking about it for a while over the years, but it's a 2 noise source system. You have the compressors down below, and you have the noise propagating from the upblast fans. And it's really interesting. You have mid to high frequency noise on the screw compressors, low to mid frequency on the upblast fans, and sometimes all the way over to the 8,000 hertz. But a lot of people will try to do one or the other. They'll try to usually put wraps, and you've seen wraps on the compressors. And that's really good, but it's a 2 noise source system, and it may not do enough. So when we look at air-cooled chillers, the first thing we want to do is look at the installation instructions and placement instructions by the manufacturer. So this is really nice. It tells you, hey, we would like you to really have 85 inches here for coil replacement. We got electric code here, maybe the 40-inch, because we got a control panel here. You can get by with 36-inch here and 24-inch here. So if the noise control solution, like a barrier wall, can fit in those space, that's what we would want to do, because that's what the manufacturer is telling us. But sometimes a manufacturer come to us and say, we got to shoehorn in something. What are we going to do? We can't follow this, but we got to keep the thing operating properly. So we take a look at that. And in that case, we can use acoustic louvers and barrier wall. There's a lot of different things. There's a lot of different things we can do, and we'll look at that right now. One option right here is for a chiller stack. Chiller stack, if you look at this, these are all perforated inner shells. So these separating baffles, which go completely between, they don't obstruct the fans. They're stacked, simply supported external to the air-cooled chiller. And the air, you pair off each fan. These are perforated inner shells, and each of these baffles are perforated both sides. And then this is a solid outer shell. So it's it's basically an insulated stack that's going to control the noise. The problem with this particular project was they have a nice equipment yard here, poured concrete, but there were condos and it was making noise and had problems at the property line. So there was noise up and over this wall. You see the wall's not much taller than these units. Well, they were with the stack. It was like a 3-foot difference. And then there was also condos on this side where I am that actually have balconies over. This was all new construction around this area. What's nice here is it actually helps control recirculation because you're extending that up more. The pressure drop is basically nil other than the perforated inner shell and friction loss. Now, you see here, you say, well, what if one of these fans blows? How do I get in there? Think of this. These have options for each of these bays. You can have an access port, a hinged access port, enough to get a person through and hand a fan through. That's really nice. But remember, a lot of times this is done via retrofit, unplanned monies. People don't want to spend for the added doors and hatches. So they say, we'll just get a hoist and pull them up and over if there's a problem. Another option is a pergola. Similar to what you just saw, but this one actually has parallel baffles at a key distance above the upblast fans. These are perforated both sides. They actually run over the fans, and it makes a difference whether it's the act hub or the blade and how this all sits. But the knowledge is there in programs that we have back at the house where we've done a lot of these. And this is a resort. In the back there, you would look out these balconies and you'd see I think it looks really nice, the equipment yard, but you heard it. And people would come in one year and they'd put them back there. The next year they'd come to the same resort, which I don't know if you guys do that. I know my family, we have some of our favorites, so we go over and over. And they'd all say, we don't want to go to one of those back rooms. And so after a while, it got really bad. So then what they did was they put these pergolas because they were just worried about the up noise. So they were worried about this. And usually, just to let you know, this is either 2 or 3 feet above the top of the fans to the bottom of this. So there's if you have to pull a fan and things like that. And then here's one if you got to really shoehorn it in. You got a skirt of acoustic louvers. You got acoustic panels above to control. You got a double door for access to pull the unit out. And then you have the pergolas at the top here. So this was a school. They were worried about noise propagating up and over. And then also out the front here was an equipment yard at the main rear entrance of the school. So we had to shoehorn in a solution. And it worked out really, really well. And when I was talking about pressure drop and the 18 dBA reduction and 10 dBA, if you take a test, now of course this was done on the equipment itself and it's operating, but at 100% load, from the intake here, the pressure drop of the acoustic louvers to the discharge of the pergola and the orientation and system effects that are in there, we were able to achieve a 0.1 static pressure drop from upstream of the louvers to down upblast. So it was really slick. And that was hence the beginning of the design back in probably 2010. And they've come a long way since. Then we can also see the wraps that you see around the compressors. Those are great. They're really cool looking. There's a lot of clasps and it's really cool, and it's there to control the noise as well. You can buy it from the factory and they're okay. But we've seen a lot where we go to a job site where they do the first maintenance on the equipment and all those clasps and everything, and the thing's sitting over here. Man, they don't. Now, I don't know. That's a management issue. Okay, that's a maintenance management, manufacturer management saying, hey, you got to put that back on after you service it. But we do see a lot where they're not back on. And so that's where we come in and we can quiet things down a little differently in this particular product. If you know, this was, I'll admit, this is cooler looking. This is really cool, all them clasps and everything. But if you look at the compressor in here on this one, you can actually build a aluminum frame system with then a mass-loaded vinyl curtain, outdoor curtain quilt these are actually on the side, top, and these two fronts. Underneath is open and into the equipment is open. But these two fronts can just pull off fender washers, lag screws, and the wing nuts and pull those right off stainless. Now you got this 2 pound per square foot or 1 pound per square foot square. You put it down. When it's time to put it back, you got grommets on here that just line up, and it's like, well, I know what to do with that. Put it back into place. So this was just to make it easier. Then equipment yards is another issue where we have a lot of equipment in the equipment yard. The equipment yard is cinder block or it's poured concrete, and so we want to quiet it down. Over here, you have a product that is perforated metal panels. They can either be flush mounted with the wall like these are, or they can be offset 1 or 2 inch. These are absorptive panels. They have insulation behind them that's suitable for outdoors. It's a perforated face. And we're just doing what this is doing, this wall panel or with that. It's absorbing sound, or what the carpet here is doing. It's absorbing those reflective sounds. Now in retrofit, this is great for new construction. It's all planned in, budgeted money. These are metal or aluminum. But sometimes you got to go in and retrofit. And another option to stay within maybe budget, or a budget that's not there at all, these are outdoor quilts, 4-inch thick quilts that are factory quilted and can be mounted. Furring strips behind can be mounted with fender washers and lag screws and mounted to soften the inside of that equipment yard. Once again, taking down those reverberations and usually obtaining, you're looking at about a 8 to 10 dBA reduction to do that. And it's a cost-effective way of softening those. Another way, we have a lot of things where somebody will have a chain link fence. This was in California next to a daycare. They have a bunch of condensers in there and air conditioners. Copper's still a premium out there, a beautiful item to be stolen in many areas of the country. So the great thing here was they actually had braces coming back from the columns to the building, and they had chain link on the top to keep people out and from the copper. And they needed noise control, so they actually took the curtains. You can see here the quilt both sides, the mass-loaded vinyl, and it's an outdoor, suitable for outdoors with grommets in it, and you can actually tie those to the chain link fence. Now you're blocking noise as well as absorbing. The important thing, though, is if you've seen chain link fences, you might have seen them bend over at times. If you put something like a curtain on there, it's going to turn into a wind sail. And those forces are going to bend that right over. So it's very important, like you see here, to either support these columns now if you retrofit something like that, or in this case was able to tie them back to the building. Air-cooled chillers, but this could be any equipment up on a roof. Can be either acoustic panels that you see here with perforated inner shell, solid outer shell, or acoustic louvers. A lot of architects are really loving the acoustic louver look. A lot of engineers will like it because if you have a piece of equipment, an air handling unit, an air-cooled chiller, or something close to that equipment yard wall, either up on a roof or on grade, it's got to breathe. And maybe you're closer than you would want. So you want a low pressure drop acoustic louver, but architects like, so that's why the engineer likes it, but architects like it because of the look. And there's a lot of different types that you can get there, powder coated finishes. It's just, that's been the big thing that people are using acoustic louvers now. And a lot of the data centers are doing the same thing. So if you look at this school, it's another one air-cooled chiller up on a roof. You got the air-cooled chillers. You have the neighbors over here. You can see from a plan view that they're up on a roof. You can see them installing the coolers, the air-cooled chillers on dunnage, putting the acoustic wall in. But the neighbors here were the ones that they were up higher than this. They were kind of right, I don't know, that maybe the property line was more at this level here. And so noise was a concern. And so had to control that noise. But that's how it works is, you know, the schools go in there, they're getting new air conditioning, everybody's happy, and then the neighbors are complaining about the noise. I don't get it. But, but that's how this all comes into play. Induced draft cooling towers are very interesting. Same type of thing. Induced draft cooling towers or any kind of cooling tower, we got to be careful with the back pressure of any solution. One item, this one was actually being installed, this was at stage 2 weeks ago. So I didn't get the final ones yet, but there's 2 cooling towers and they needed to quiet them down because over here is a daycare, and then right over here, kind of that way, over in here, is a school for the deaf. And people say, well, if they're deaf, they can't, why do they care about the noise? But they do, they can feel it, they can sense it. And also this looks like one big monster when you got a bunch of little kids around, and this looks like a monster. So it was also out of sight, out of mind with the acoustic wall, perforated shell, double wall construction, solid outer. And that was it going into construction. That's one great solution because look, you could get far enough away. It takes care of the inlet. It was able to, people were down lower. It was able to take care of the discharge up blast fan. Sometimes you can't do that. Sometimes you may need a barrier wall and you might need an acoustic stack as well, where you actually have simply supported external to the cooling tower and you have these in red acoustic panel stacks that have perforated inner shells, solid outer shells, and that controls the noise up and over, but also if you have noise, balconies or something above that, which are high-rise buildings. And you can see it here. This one's actually at Niagara Casino. It was many years ago, but picture this on a smaller scale because we've used it a lot, but this is really neat where these are the stacks simply supported. You can see controlling the noise of the upblast fans. It's even more interesting where you have maybe a 10-foot diameter upblast fan and you got a hub, is they have that internal sound bullet. Remember we talked about AMCOM, we saw that internal sound absorbing bullet on the fan. That matches the hub of the fan, and there's neat airflow characteristics that you can make sure you control to keep that back pressure very low. And then also here you have banks of intake silencers. Equipment yards. This was actually one that had a bunch of weather louvers on it. This is at University in Texas, that really, in San Antonio, that really gets into tennis. I mean, really gets into tennis. And on this side where I am, they have many tennis courts. And you know when they're announcing in tennis and they're announcing really quiet and they're talking and this, well, you couldn't hear them. You couldn't hear the people. And what happened was they got brand new, they put this cooling tower yard in here, and they got brand new cooling towers in here, very large. I mean, you can see the height of the door, and this is two tall towers, and they had weather louvers on there. And it would have been great. They looked beautiful, but it wasn't quiet enough. So within just a couple of months, the first season, when they were playing tennis again, they tore out the weather louvers and put in acoustic louvers. The final thing that we talked about is generator rooms, and I think I got a couple seconds. Okay, I got a little bit. So generator rooms are very interesting, and I talked earlier where all the noise is in the generator room, but that noise can eventually break out from the outside air intake and the discharge downstream of the radiator. Sometimes we have to do a combination. There may not be footprints or enough real estate within the building to put rectangular silencers in downstream of the radiator or downstream of the outside air intake and upstream of downstream of the radiator. You may have to use acoustic louvers. That's cool. Acoustic louvers are made in 4-inch thicknesses up to 2-foot depth. You may need some more help yet, and you might want to absorb sound within the space of the room itself to dull the room down like we did the equipment yard. So when we look in here, there's a lot of different things you can do in a generator room. You can actually line the walls with absorptive material, which is actually, you can purchase and lay in space. It usually comes in 4x8 or custom sizes. You can do that. That absorbs sound. It's also Class A fire rated. And then here you can actually, in a space, you can add it up into the rafters and joist area. And then over here, you can actually line the ceiling as well. Because what we want to do is if this is a generator room, and there might be 4 generators in this room this way, boom, 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 parallel, we want to, before we even worry about noise breaking out of the room, once it gets out of the room, we want to try to quiet the noise levels within this space. Maybe it's running, you got 3, or maybe there's 5 generators in here and 3 running at a time. And those 3 are running combined at 112 dBA. Well, wouldn't it be nice if we could bring the levels in that room down 10 dBA, down to 102 before we're worried about them even breaking out of the room? So that's the gist behind this. There's other products too, the PET, polyethylene terephthalate, recycled plastic water bottles, the big fad in acoustics. It's very good. These are 2-inch thick. This particular one is at a hydro plant. But it can be used in a generator room. And so that's another way to absorb sound. A less costly way would be to put in a quilt, 2-inch and 4-inch nominal before it's quilted, and just mount that to the walls or hang it. It's very light. We just want to add that absorptive material into the space to reduce the reverberations. Or you can have hanging baffles. These happen to be 2 foot tall and 8 foot long and 2 inches thick. And then you can have wave baffles, which actually kind of wave when you mount them, and that gives you more surface area for sound absorption. And this is at a power plant generator site. So we're just trying to reduce the noise levels within that space. And then the perforated metal panels that you saw before in the equipment yard, same type of thing. Different products, you can kind of see everything's independently tested. And I think this is a good time to say this, is that the reason you can solve all these issues is because you're basing it upon independent tests of the products in an independent lab, NABLAC accredited lab, per ASTM E90 for sound absorption, E90 for sound transmission loss, C423 for sound absorption, E477 for silencer insertion loss and things like that. Acoustic louvers, big fad, but this is what we were talking about then in the end, is right here you got, this was a rear entrance where you're sitting, you came out of the rear entrance of a hospital. And when they fired up these 4 generators at that rear entrance, which was only about 60 feet away, it was 88 dBA when you walked out of the rear entrance of the hospital. So you're leaving the hospital, you feel much better, then you leave the hospital and you go deaf. But no, you don't go deaf, but it was not what they wanted. So they wanted to quiet it down. Once again, took out a bunch of weather louvers here, 11.5 hour, and put in 2 foot deep acoustic louvers. These are 14.5 foot square, each of these. So, and this was the downstream of the radiators. And then the outside air intake on the other side was what you see similar to this. This is a big data center this was actually the other side for the outside air intake. But over here, this is a Citibank data center where they had multiple generators, and this was the fresh air intake silencer banks. These were 16.5 feet tall by multiple units that you stack up. But just wanted to show you that. So we want to control the noise within the space in the generator room, and then control the noise breaking out of the generator room. Here's this, I had it up here, I forgot. So I have the standards up here. And then just to say environmental outdoor noise control is of great importance. It really is. I like it now that we're not seeing as many things budgeted out of projects. I think the word is out, and it's better to do it now if you can. And sometimes you can just relocate the equipment. Educating owners and communities on the available noise control options, using the most up-to-date acoustic algorithms, design standards, and applying independently tested products. We talked about that. Will yield a solution satisfying to both the building owner and the surrounding community. So that's what I like to do. That's what my team likes to do. It's fun to work with the communities and also manufacturers of mechanical equipment, and working with the architects and engineers. So if you have any questions, let me know. The article's online on InMotion, and that's what we got. I'm here if you have any questions. Any questions? Perfect. Good crowd, man. I don't know how many we got, but man, it loaded up. Well, good crowd on no questions yet.